Hello everyone, welcome back to my channel again. I am Yashoda from LNDDI Japanese IT University. So in my last video, I have discussed about queues, which is a linear data structure. And in this video, as I said, I'm going to discuss about non-linear data structures, specifically about trees. Let's dive in. Trees is a nonlinear hierarchical data structure which represents data with a parent-child relationship. This is what a tree looks like. Tree components consist with nodes and edges which connect nodes, and root node, which is the topmost node, and parent nodes, which sometimes consist with child nodes, which can be leaf nodes without children, and internal nodes located between root node and leaf node. Trees can also have different levels. This tree is a tree-level tree. Degree of a node is about how many child nodes one node has. In the selected node, it has 3 child nodes, so the degree is 3, and here it is 2. Depth of a node is a unique path from the root node to that node. So here, the depth is 2. The height of a node is a maximum depth of any node within the tree. So in this node, it is 1, and in this node, it is 2. And if it is just the root node, we call the height -1. A tree traversal is a systematic way of accessing or visiting all nodes in the tree. There are 2 ways called breadth first and depth first. Breadth first traversal accesses the nodes in the tree level wise. As you can see, it goes to each level and accesses the nodes in that level respectively from left to right. In the depth first traversal, there are 3 ways called in-order traversal, pre-order and post-order. In in-order traversal, we visit the first node of each level that has not yet visited. Pre-order traversal starts from the leftmost child node and access all the nodes in that subtree, then visit the root node, and then visit the leftmost child node in other subtree and access all the nodes in that subtree. Post-order traversal starts from the leftmost child node and access all the nodes from bottom to top in that subtree, and then visit the next subtree and access all the nodes from bottom to top, and finally visit the root node. There are countless tree types, and from those tree types, today we are going to look at heap tree. Heap tree is a complete binary tree. So before going into heap tree, you should know what a binary tree is and what a complete binary tree is. So a binary tree is a tree where a node can have 2 children at the most. Complete binary tree is also a special type of binary tree where each level is fully filled except for the last level, but the last level should also be filled from left to right. This is an example for a binary tree where each node has 2 children at the most. And next is the example for a complete binary tree. See, the last level is not fully filled, but it is filled from left to right. The rightmost end should be the one to be empty. So if you look at the heap tree properties, it should be a complete binary tree, and there are 2 types called max heap and min heap. If the parent node is greater than the children nodes, then it is called a max heap, and if the parent node is lesser than the child node, it is called a minimum heap. And now let's look at the maximum heap and minimum heap separately. A maximum heap is a tree where the parent node should always have greater value than its child nodes. The root node is the largest value you can find in this tree, and from top to bottom, the values reduce as you can see. So the leaf nodes are the lowest values you can find in this tree. For minimum heap, it's the other way around. The root node has the smallest value you can find in the tree, and from top to bottom, the value increases as we proceed to the bottom, and in the bottom, in the leaf nodes, you can find the largest values. By any chance, if any of these heap properties are violated, then we have to heapify the nodes. Heapifying is a process of fixing the offending nodes by exchanging them. When inserting the nodes, we are inserting them to the right side of the bottommost level, and then we heapify to remove the violations. Deleting process is also similar to insertion of nodes. First, we are replacing the node we are about to delete with the bottommost node of the right side, and then we delete the rightmost node. Then we are heapifying the tree. And that is all about tree introduction and heap trees. Thank you for watching. See you in my next video. Bye.